Hello and welcome back to another video. In this problem, we're asked to verify another possible choice of delta for showing that the limit as x approaches 3 of x squared is equal to 9. In example 4 is delta is equal to 2 and epsilon over 8, the minimum of those two. So what we want to do here is, first of all, use the precise definition of a limit, because that's what we're getting at here, which states that the limit as x approaches a of f of x equals L if for every positive number epsilon, there is an associated delta that is also positive, such that 0 is less than the absolute value of x minus a is less than delta. If this is true, then the absolute value of f of x minus L is less than epsilon. And so what we have to do here is first plug into these inequalities the values associated with this exact limit. So a is the value that x is approaching. So we have 0 is less than the absolute value of x minus 3 is less than delta. F of x is the function in the limit, so that's x squared. L is the value of the limit, so that's 9, and this is less than epsilon. And first of all, if we have the absolute value of x minus 3 is greater than 0, this is the same as saying x minus 3 is not equal to 0, because this is the only valid output of an absolute value that we are eliminating by saying that it's greater than 0. Therefore, x is not equal to 3. However, we already know that x is not equal to 3 because we're only looking at the limit as x approaches 3, not what's happening at 3. Therefore, we can say the absolute value of x minus 3 is less than delta. We can also say that if the absolute value of x squared minus 9 is less than epsilon, that is the absolute value of x plus 3 times x minus 3 is less than epsilon. We can say this because this is the difference of two squares, so you add the two things that are being squared, and then you subtract them, and then you multiply those together. If we have the absolute value of x plus 3 times x minus 3 is less than epsilon, this is equal to the absolute value of x plus 3 times the absolute value of x minus 3, and this is less than epsilon. And what we want to do is we want to have a relationship between delta and epsilon. And we have x minus 3 is less than epsilon, and absolute value of x minus 3 is less than delta, so we're close. However, we still have this absolute value of x plus 3 on the that's being multiplied in this equation. So we can't just create a relationship directly, but what we can do is we can pick a constant c such that the absolute value of x plus 3 is less than c, right? So we can pick any c such that this is true. And the reason we're doing this is because if we therefore multiply this out by the absolute value of x minus 3, we get the absolute value of x minus 3 times the absolute value of x plus 3 is less than c times the absolute value of x minus 3. And we can make c times the absolute value of x minus 3 be less than epsilon by taking the absolute value of x minus 3 less than epsilon over c. Right, this is all doing what we did in example 9 itself. But the change here is we are going to pick a different value, or range of values rather, centered around x is equal to 3. Right? In example 4, they say, okay, let's limit our point of interest to within 1 unit of 3. Therefore, x minus 3 absolute value is less than 1. All right, that's what they did. But here we're going to use 2. So if we say the absolute value of x minus 3 is less than 2, then x minus 3 is less than 2 and it's greater than negative 2. If we add 3 to both of these, and then actually we're going to have to add 3 again. 2 plus 3 plus 3 is 8. We have x minus 3 plus 3 plus 3 is plus 3. And 3 plus 3 minus 2 is 4. Therefore, we can say that the absolute value of x plus 3 is less than 8, right? So no matter what value you put in for x plus 3, if it's between 4 and 8, that means that its absolute value is less than 8, since this is the biggest one. And if the absolute value of x plus 3 is less than 8, and the absolute value of x plus 3 is less than c, a possible value for c would therefore be 8. Therefore, we can say c is 8. And if we can then plug it in and say the absolute value of x minus 3 is less than epsilon over c, becomes epsilon over 8. And the absolute value of x minus 3 is less than delta. Therefore, delta equals epsilon over 8. However, this isn't the only value that we've assigned delta to. When we did the absolute value of x minus 3 is less than 2, we said that delta equals 2. So that's another option. How do we choose which one is which? Right? Which one is our actual delta? Well, it depends on how big epsilon is. Because delta is going to be the more restrictive of the two possible values, the smaller of them, because that's going to limit you to a smaller range around 3 for your values of x. And so we say that it is equal to the minimum of these two values, 2 and epsilon over 8. And depending on what epsilon is, right, whatever epsilon over 8 is, between 2 and that number, the smaller of those two is our delta. And therefore, we get that not only can we solve this problem as we did in example 4, but also that delta can also be the minimum of 2 and epsilon over 8.